Alright, so we're looking for the partial derivative of f at xt, or basically we're looking for the gradient. So the gradient would be defined of f as del f over del x, comma, del f over del, which is really what they're looking for in this question. But they sort of pose it as a two-part question. Same thing, just a few side notes. If you have f as a function of xt, there's a few labelings that so you know for the most part that f is the label for the now we can say here for the x is the spatial, you can call this x the spatial variable and this t the temporal. It's not tempora. Temporal just means over time. So what we're saying is that we have a function of space and time defined as the product of a linear function and a complex or really advanced sinusoidal function. So for del in terms of del x, this would be when we let t be. Now just to make it more clear that t is constant, I'm going to give it a variable k, and usually in math we denote constants as n, c, k, l, whatever. I'm going to use k. So everywhere where there's an, just to make it more clear that we are working with x only. So we have 3k to the 4 minus 2kx. We take the derivative of this, it'd be the product rule. So left times the derivative of the right, so negative sign of 3k4 minus 2kx times negative 2k times the plus the derivative of the left, which is 1 times the right. Cosine of 3k to the 4 minus 2k x. 2k of 3k4 minus 2kx, okay, plus cos of 3k4 minus 2kx. So this is how the function of the derivative works along the x when t is constant. Now we need to know how it functions when x is constant. And the same way I made t a constant, I'm going to make x a constant this time when t is constant. Now we need to know how it functions when, and the same way I made t a constant, I'm going to make x a constant this time. So del f, del t, I'm going to let, then you have m times cosine 3m to the 4 minus 2m, and then we have the derivative of cos as sine, negative sign, times 3t to the 4 minus t to the 4 minus 2mt times the derivative of the inside, which is 12t to the 3. Okay, so this is negative m 12t, oops, 12t to the 3 minus 2m sine of 3t4 minus 2mt. Alright, now for both of these, I'm going to replace their constants with the actual value. So this is t, these two are t, that's t, and that's t. This will be x, x. This is x, 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 and x. So for me, when I replace that variable with a known constant symbol, it's a lot easier for me to do the partial derivative.